I've placed in the link in the Skype chat. I've placed the video from the Hamarii 8 of the eclipse. Now, I don't know how many Globelings want to look at this and have their brains fried, because you've seen the size of the eclipse that's going to happen across the US. So look at that and then compare it with this.
Yeah, that's
for me. I make sure that my position is stated clearly that the flat Earth describes the eclipse perfectly for me.
Yes.
Perfect. And in fact, the shadow makes sense with the being close to the sun, all that. But what I'm saying is that I will always argue for the truth. So when people use the wrong drawing or the wrong scale or the wrong idea, I'm going to point it out every time. I'm not going to just sit there and say, well, they're arguing on behalf of the flat Earth, so I'm going to let them show incorrect models, because that's what I hate NASA for. Everything NASA shows us is the wrong scale, is just to get a point across. It's not really accurate. And so I see the same thing going on with if we're going to call them out for the eclipse, there's so many other things to call them out on. But I mean, the eclipse being one of them, I agree. Definitely the size of the shadow and other things like that. But I feel like we're going to the wrong arguments. I don't think, if somewhere says that the West Coast is supposed to see the eclipse and then the East Coast is supposed to see it 5.5 hours later, that's a big deal. That should be brought up. But I hear it being brought up, but I don't see any evidence of it. Just people are just saying that. And I have not seen that yet. So I mean, I'm just going to point those out, because I think that there's so much wrong with it that we don't need to invent things wrong with it.
Yeah.
Well, I think that sorry, Antonio, I think that the whole thing with the light and shadow, and I'll pass the mic right to you, is that's what we see in reality. Okay, if you take any spherical objects and any large omnidirectional light source and start playing with light and shadow, you're going to see certain things. One thing that you're never, ever going to see in reality, unless you start getting into lenses and stuff, which we mentioned a little bit before the show, you're just simply not going to see tapering conical shadows away from spherical obstructions of light in reality. So, again, we have to swallow a lot of just rubbish in order to coalesce with the heliocentric theory. I think that's the point.
What Jaron's saying, and I get it, and it's true. If you have a really wide light and you put it close to an object, that white light is going to blur the edges and give you only a very small shadow, as long as you've brought it into focus with the surface that it's going to fall on. But when you take that same bright light and you move it away, without moving the shadow casting objects from the focal point, as you move that away, the blur of the shadow, so where it fades, gets wider and wider to the point that it gets to the size of the object. It depends how much you move the thing away. But if we look at this graphic, for goodness sakes, the shadow on this graphic is at least as big as Papua New Guinea. I mean, that is a ridiculously large shadow. Now, it's lucky for them that they're showing it over the South Indian Ocean, or going on to the Pacific. If they showed that over America, it would be half of America at least. Now, if we take, Jaron, what you said about the time between the western coast and the eastern coast, one of the things that we all love doing is questioning what they tell us, what they give us. So I'm looking at this, I'm thinking, okay, I'm going to ignore for now Eastern Russia. I'm going to ignore Western Europe. I'm going to ignore that. 1 hour and what? 1 hour and 25 minutes over the US. That's what they say. Something like that, yeah?
It might be more, actually. I think it's more like 2.5 or something.
Right. But this is the thing. If you look in various different astronomical places, they give you different results. It's like, okay, why are you not in accord? If you're all using the same model and the same math, you should all be in accord. There shouldn't be a few minutes here, a few minutes there, half an hour here, 40 minutes there difference, and there really are. So when you look at this, you go, well, how fast is the shadow traveling? How wide is the US from northwest to southeast?
Yeah, but here's the problem with that, and this is the problem with what people are doing. People are taking the speed of the shadow and thinking that they can put that across the entire Earth. And in their model, the Earth is a ball, meaning you're going to have the shadow move at a different speed. It's going to move incredibly fast, then it's going to move a little bit slower, then very slow, then a little bit faster, then extremely fast.
Yes.
Okay, so that answers the question of why people have different numbers, because some people are just taking it as, how fast does the shadow move? It moves at this speed. Okay, this is how fast it goes across the entire United States, which is not correct.
No, but this is them. This is the astronomers with their numbers. Like, okay, you can understand an amateur or somebody just looking at it, not thinking, not factoring in the shape of the shadow and how much more it covers in less time, which is why it's so much faster when it's on the edges of the globe, and so on. It's like their details are giving you different readings.
Yeah, just, Jaron, this should settle you a little bit. Okay, so if you go to Wikipedia, the source of all truth in the world, the totality, the maximum eclipse totality duration is only 160 seconds. So that's a couple minutes, but the partial beginning UTC times is 1546, and then it goes to total begin is 1648. Greatest eclipse is 1826. Total end is 20 and 1 minute. That's 20 hours and 1 minute, and the partial end is 2104. That's a total of about just over 5 hours. So that's what Wiki's claiming.
Correct. But somebody said earlier that it's 5 hours across the United States, which is incorrect. The eclipse goes all the way across from the ocean to ocean. It's not.
Oh, okay. So we want to make sure we get this right, at least in terms of the actual numbers to expect, right? Yeah.
Right, and that's all I'm saying is that let's make sure we're arguing the right thing. Potter's Clay came out with a video, I think yesterday. A bunch of people commented on where he said that